could be the airports or railways, where I might have booked the tickets for going from source to destination. So somewhere, or maybe my banks for that matter, where I'm got a saving bank account or the credit card accounts. So somewhere somebody is continuously fiddling with my data. So we say continuously 24 by 7 by 365, data is on the move. Now that brings to a logical conclusion, what kind of data we are dealing with. So there are two broad categories, there are multiple categories rather. There are two broad categories which would deal of is a freely accessible data and the proprietary data. I think which is very well known, FOSS, free and open source data, and the proprietary company-oriented data as such. And that this is a big question. Can the data be secured? Because this is where blockchain technology will step in. Because first of all, we need to realize what was the need that the technology came. Only then we'll be able to exploit the full benefits of the technology to our advantage. So the big question that need to be answered is, can the data be secured? And that leads to the areas of data privacy and the data security. Now these are the not only buzzwords, but these are the major issues or major challenges which are going to be very well known in the cyber world, in the area of cyber security. That where does the data privacy ends for the individual, and where does the governments actually enter in, or where does the companies actually enter in. So these are very threadbare critical issues that require a lot of debate in the cyber security world, that how to deal with the privacy and security issues of the data. Now when we talk of data, what kind of data I need to secure using a blockchain, or for that matter cryptographic techniques and algorithms. Is it my date of birth, or my name, the name of my parents, my qualifications, my mobile number, my email ID, maybe the name of my residential address, the workplace address, the name of my spouse, the name of my kids, their qualifications and details. Am I going to use a blockchain technology for providing a protection to such a kind of data? The answer is no. Why no? Because the data is already known to so many people around me. My employer have access to such a kind of data, because when we join the company, we need to disclose all our personal details. So my neighbors knows about it because they have been living with me for the last 10, 20, 30 years or so. My friends knows about this information. So there is no need to provide a protection to a data using a technology like blockchain, which is already known to so many people around me. Because when you design and develop a blockchain technology, it costs, it's expensive. So you just can't waste the resources on providing a protection to such a data which is already open source. My neighbors knows, my friends knows, my relatives knows, my employer knows. If I got my kids in the school authorities knows about the access to such a data. So why to waste a blockchain? Why to waste the resources in providing a protection to such a kind of the data? Also, we as individuals, we all know we are keep on uploading so many number of posts on the social media platform like WhatsApp, Facebook, Instagram, Snapchat. We keep on tweeting on Twitters also. We keep on posting on the LinkedIn. We keep on uploading the reels on Instagram. So much amount of the data we as an individual already share on the web. So once the data is being shared by the individual themselves, then why should I provide a protection to such a data where it is not valuable to user himself? Because if the data would have been valuable, he would not have uploaded on the web free of cost, right? So there is no, again, why to waste a technology? Why to design and develop a blockchain for providing protection to a personal data of the individual, which is not critical to him? That is why he's posting on the social media platform, the SMPs. So now that comes to the final answer, that this is what I'm going to protect using a blockchain technology. That means my biometric details. When we got our Aadhaar card made by the UIDAI, then they took all our biometric impressions, the thumb impressions, the iris, everything they captured, the entire body image as such, and they're preserved in the databases of their own UIDAI. My bank account details, like my saving bank accounts, my demat accounts, if I'm doing a stock trading, my debit card accounts, my credit cards account, my Paytm accounts, my PhonePe accounts, so digital wallet details. So this is the data which is very critical to me because it involves the financial transactions. The point I'm trying to emphasize is that The data which is already in the free and open source, do not waste a technology like blockchain because it cost. So why to waste on the providing protection to a data which is already free, open source, devalue it. User does not have a user is himself posting on the social media platforms. So why should I provide a protection to such a kind of data as an IT company, as an individual? But this is the data which is now being shared on the slide, the biometric details of me. It's very personal to me. My bank account details, my digital wallet details. So I want that whosoever is using my such a kind of data should take a permission from me, a written consent. That yes, I as a user is ready to give a authority to access my data, which is very personal and professional to me, my financial data, my critical data as such. So this is where we can use a technology like blockchain. So first of all, that was what I started the tone of the talk, that we should realize where to use, how to use, when to use, we'll discuss later in the course of the lecture, in the course of the talk. But we must realize that we should not waste. There's no point in designing and developing a blockchain for any kind of the data. We first of all should study the application, the project on which we are working, and should understand the need and the requirement, whether such a data requires a protection of hashing algorithms like MD5 and the SHA, because the basic backbone of the blockchain technology is all hashing techniques, the MD5 and the SHA, message digest 5, and the secure hash algorithm. Should I use it? Because they also cost a lot. Resources are being consumed. So as a first level, I as a application developer or a full stack developer need to realize that whether I should use a security team expert, I need to realize that whether I should use it or not. So if I have the answer yes, then it should be any of this kind of a data, financial data, transactions, real-time commercial operations on the web which are happening. They need to be provided and protection to the blockchain technology. So we say one of the most acceptable solution in today's environment to solve all this problem of providing protection to data is the adoption of the blockchain technology, for which we are all gathered here. Now, blockchain technology is a part of the broad world of information security. So, and what are the prerequisites we are looking for from the generation X, from the what is the next millennials? What is the knowledge base we required when we go for the technology like blockchain? First of all, a good, sound, working knowledge of cryptographic techniques. There are many number of cryptographic techniques already prevalent in the world, like Caesar cipher, Wiener cipher, rail fence cipher, affine cipher, hill climbing ciphers. So many kind of the technique already exist. Overall, if you largely say the world of cryptography is divided into two broad categories. One is the symmetric and the asymmetric. Now, those of you might be starters, which might be naive, who may not be aware about the cryptography as a subject. Cryptography is a branch of computer science that involves the process of transfer of data in the presence of adversaries on the web. Means the enemies are there, cyber enemies, cyber criminals, cyber attackers, cyber hackers, they're already on the web. Now, using your own sound knowledge of cryptographic techniques, how you can safely and securely transmit the data over the web. Something like what when we teaches in the class, we see some of the students are able to do WhatsApp on their phones. So they're also smart enough. They are right in the eyes of right in front of the teachers. They are able to do it without the teacher coming to know about it. So that's about the general application of cryptography. How beautifully and how well you are able to do it. So they can browse on the web right there in the teachers. They're on the desk. They do it. Go to the social media platform, check out the reels in Instagram, whatever they want to do it. So same with the cryptography, how successfully you're able to transfer the data. Now, I just said that we have got two branches of cryptography, symmetric and asymmetric. Now, symmetric cryptography says we'll have two broad terms, encryption and decryption. Encryption means conversion of the data from the plain text to ciphertext by applying technique, like what we say cryptographic technique. So like Caesar cipher. There's a general equation for Caesar cipher like P plus K mod of 26. The K is a key. So every technique requires a key to operate. And 26 is the number of alphabets of the English language. So there is, if you take a real-time example, just like in the night when you go to sleep, Before that, your parents usually ask you to go and lock the front door or the main gate of the house. So you bring a key, you bring a lock, you go there and lock it up. So you're using two things there. One is a lock and one is a key. Now the lock here is the algorithm and key is more like chabi which is used to drive the lock, the algorithm as such. So that's why if you see we have got multiple levers of lock, 5 lever lock, 7 lever lock, 9 lever lock. That lever word here is introducing complexity in your algorithm. Because if you keep the algorithm very simple, anyone can break it. So what's the point in putting a lock, which is very so naive, so easy, anyone can hack it as such. So we need to design two things. One is a lock, one is a key. That means one is a technique or the algorithm and one is a key. So there are many number of the algorithms which have come over a period of time, like DES, Data Encryption Standard. You might have heard, you might have studied, depending on which year you are in your UG or PG. Or we have got AES, Advanced Encryption Standard, very popular algorithm which was introduced by John Deeman and Vincent Richmond. I still remember there was a competition which was started by the US Department of Defense in '97, wherein they were looking for a successor of the DES algorithm, Data Encryption Standard algorithm, which was introduced by the IBM and which was being used in the industry for almost 20 years. So they were looking out for successors. So nowadays, if you see, we have got Smart India hackathons, where we are looking out for the fresh generation next uh, experts who can actually join the government of India's initiative to design and develop the next generation of products. Same way, US Department of Defense started the security-based competition, wherein they threw in open that we are looking for algorithms which can be successful for DES and have better understanding, better solutions as compared to DES. Means much more plus level of the DES algorithm. And there are multiple rounds. So competition ran from 1997 to 2001. So for 4 years, there are multiple rounds. So initially they got 50 algorithms, then they shut it down to 32, then 16, then 8. Then finally that AES, Advanced Encryption Standard Algorithm, introduced by John Deeman and Vincent Richmond, finally was selected as one of the best successor to the DES algorithm. Until now, I tell you, because I've been working there security quite a lot, for the last 20 years, AE has been a very good algorithm. Good, not doesn't consume much of the resources, lightweight, easy on machine, do not drain much of the resources. And security wise, I don't say it's a 100% bug free or foolproof algorithm, but still very good, considering it's on the part of the open source community as such nowadays. So 20, if any of your algorithm lasts for 20 years in the area of security, I think it is overlived. Shelf life is beyond, because most of the algorithms have their shelf life in maximum 3 to 5 years. Because after that is cryptanalysis happen and the algorithms are broken up by the hackers. They come to know about it. They are able to decrypt it. That what were the lines of code, how many number of iterations were used, what was the substitution table used, what was the permutation table used, what was the combination used. They're able to decipher it. So, but the AES has been able to almost long as good as 20 years in the time span. Another broad category is the asymmetric algorithms, like one of the RSA, Raivis, Shamir, and the Edelman algorithm, RSA algorithm, what we commonly say. Again, an asymmetric algorithm which uses two keys, one in public key, one private key. And all these algorithms are wonderful. In the sense that, since it's the ACM talk, we can also give credit to the ACM that in 1967, ACM started the award called Turing Award. Now, why did it started the award? That's also one of the reasons. We don't have a Nobel Prize in computer science, because if you look for outstanding research work in the area of physics, chemistry, and biology, worldwide every year, the Nobel Prize is given to some of the outstanding to the per scientist, maybe in the work in the open source or proprietary as a part of the IT companies, or maybe the research labs of the universities. So for outstanding research work, they're awarded because a breakthrough research has come. But in computer science, we don't have a Nobel Prize. So what did the ACM did in 1965, or rather 1967 to be precise, they started the Turing Award in the honor of the Sir Alan Turing, who has done a lot of work in the area of computer science. So those of you who might not be aware with the work of Sir Alan Turing, must check out his profile on Google. There are certain negative things also written, there are positive things also written. So just go for the positive aspect, because we also need role models for the younger generation. So just look out at the work he has done. are tremendous, considering we are talking of late 40s and early 50s when the Second World War rather was going on. And so at that point, resources were hardly there. But then also they did a lot of work. Turing machine is one of the classical example, which we still relevant today as such. So right from 1967 to if you look at 2022, so almost 33 plus more than 50 years have passed by. Considering the population of India and the number of engineers that churn out from the engineering colleges with the degrees every year for the last 20 years, I think the number of awards should be more than 15 or 20 or 25, isn't it? Because we are hardworking, Indians are by and large hardworking, that's why they're so successful abroad wherever they go. But then we lack somewhere good qualities in research. That is why the sad state of affairs that a company like ACM, who started this award way back in 67, with almost as same prize money as the Nobel Prize. But then still, we as the Indians have been able to get only one award. That too in the year 1994. I will not tell the name of a person. For the reason that I want you as a student to check out his profile. Just write on the Google ACM India Turing Award in the year 1994 and you will come out his name. So let's keep the name as some suspense, secret, so that some inquisitors come into you and you check out his profile. And he was awarded for his work in the area of artificial intelligence. At that point of time, he was in US, working in the area of medical sciences, where he was applying the AI algorithms, supervised and the non-supervised learning algorithms in the area of the medical sciences. So for that, he was awarded Turing Award. So it's unfortunately a sad state of affairs, isn't it? That we as a country with a huge amount of population, with the thousands and lakhs of engineers coming out every year, but still we have been lacking in the core area of research in the area of the. So let's all start working. That's why even if you look on the independence, even the Prime Minister of India from the Red Fort, he said, Jai Anusandhan. He as a Prime Minister of the country is asking the community to take up a research at the grassroots level, come up with the brilliant solutions, ideas, innovative products, which can touch the society, which can come up with a solution to the problem faced by the society, make the life of masses much more simpler. That's where the now core focus is. And for that, they have also started the Make in India initiative. Incubation centers are coming up. So maybe if your college, I'm not sure, or maybe your university to which your college is affiliated, can have got the incubation center. Go start your own IT company. I did it with my own university. I started a company called Dept Technologies, wherein we are trying to design and develop our products for the people with disabilities. So your mission should be clear why you want to launch the startup company, but then try it out. So coming back to the core technical talk, why did we venture toward the ACM Turing Award? Because RSA were awarded the Turing Award, the Raivis, Shamir, and the Edelman. One of the most widely accepted and beautiful algorithm in terms of security, widely used in the area of information security, the RSA algorithm. Then we also have got the hashing. What we say, now there are two algorithms, very popular algorithm, the MD5 and SHA, Message Digest 5, and the SHA secure hash algorithms. There are two algorithms here. Now, either I can use these algorithms because JCA is a Java Cryptography Architecture API, JCA. Or what I can do, I design and develop my own hashing technique. But then it's not simple, it's not easy. First of all, we need to understand what does hashing actually means. And what are the MD1, MD2, MD3, MD4, MD5 algorithm, message digest algorithm, again introduced by the RSA guys. Or what is the SHA, secure hash algorithm, what we call SHA algorithm, SHA 32-bit SHA, 64-bit SHA, 128-bit SHA, 256-bit. So we need to have a good understanding of the hashing if I want to make a long-term career in the security, or maybe I'm planning to do a project as a part of my BTech 8th semester, or maybe as a part of the MTech final year dissertation work as such. Also what we call map skills, what we call mathematics, algorithm, and programming. So map skills also play a very, very important role if you want to make a long-term career in the area of security, primarily targeting the blockchain technology. So mathematics, algorithm, and the programming. So it's a deadly combination. It works well if you have got a good knowledge of all the three areas. If you're good in mathematics, you're bound to be good in algorithms also. Okay. And same if you're good in algorithms, you're bound to be good in mathematics also. So it's a good combination role that takes actually. This is some of the research papers we carried out, so I can just skip it for the time being if you are a UG student. Yeah. let's come to the core stuff of the blockchain. The real credit goes to a guy called Satoshi Nakamoto, because he started this venture of going into the cryptocurrencies and the digital wallets and designing the blockchain as such. And he was given the credit of implementing the world's first blockchain. He also been given a credit of deploying the world's first decentralized digital currency. But then, who the real Satoshi Nakamoto is? Are we able to get the answer to it? Again, the information security world is confused because we do not know who the real Satoshi Nakamoto is. Maybe because he's working as in disguise, he has hidden his credentials, because most of the time these are not legalized. Cryptocurrency is not legalized by the countries. So at that point of time, way back almost 13 years back, 2009, he came up with the technology, but then he withheld his own name for the simple reason that the law of the land may not get better of him. The real person who was very considered close to Satoshi Nakamoto is Dorian Nakamoto, because he was also active in the same era, between 2007 to 2010, a Japanese scientist. And sometime people believe that he is a real Satoshi Nakamoto. He has just changed his initial name just to work in disguise so that the law of the land does not get caught him up. And even because most of the countries, still the problem is the cryptocurrencies are not legalized. So he wants to make a contribution, but then he is also afraid that he may not get caught up in the legal web. So the real answer, who the real Satoshi Nakamoto is, still not known as such. We can't pinpoint that he is a person who came up with the concept for the very first time. Though he still exists, he still lives, but then we're not sure of it. Maybe in some of the document or literature, if you see, they also say it's a blockchain technology. The technology was introduced not by a person called Satoshi Nakamoto, but by a company. And the company withheld his name and just used the keyword like Satoshi and Nakamoto. So it could be the work of some company also, IT company for that matter. Now let's look at the world's first blockchain introduced by the Satoshi Nakamoto. So let us go to the portal and see what he did for the very first time. Are we able to see the website? Anyone can say yes or no?
Yes, sir.
Yes, sir.
Okay, thank you so much. So if you look around it, I will just zoom it up so that you can have a broader idea. Yeah, Bitcoin block number 1. It was mined. Mine means you are creating the block in a blockchain. That's what the whole mining come actually. Simple meaning. There are multiple more points in mining, but to start off, if you're a beginner, then mining means you're creating something. Are you modifying? Are you editing? Are you deleting? We'll talk later, if the time permits us. But mining for simplest means you are creating something for the very first time. It's more like a coal miner. They are going to the coal mines and they're digging out coals. And sometimes they might dig out the diamond also. But these are the miners who are extracting the information, extracting the coals. So this block was mined on, if you look at the year, 9th of January 2009 in the morning, 8:24 a.m. by some unknown person, because he has never staked claim to the credit that he is a person who has done the work. So that was the world's first block to be added into the blockchain. And this is a hash. Now for the generation of hash, again, you need to have a knowledge and understanding of cryptography. That's why I started with cryptographic techniques and algorithms. If you have a good knowledge of cryptographic techniques and algorithm, the journey in the blockchain becomes very simple and easy. So don't jump shoot. Don't get to the blockchain on board instantly. Have your strong fundamentals first in place. You must have a knowledge of it so that you can use the blockchain to the best of your ability. Technology has arrived. It is there. People are working on it. They are designing and developing blockchain both for the public and private platform. Public means if I'm working, for example, the entire world, cryptocurrency like that's a public. Many people are using it. They're dealing with Ethereums. They're working on remix or Solidity. It's all public platform. But yes, if my bank, the private sector bank, is designing a blockchain for securing the customer's data, the data of the customer only of that particular bank. Like we have got CIF number, customer identification number, the names, my account details, how much amount of money I've got in my account, my credit card information. Because if you look at the credit card, we have got credit card number, a 16-digit number, CVV, which is a 3-digit number, and the expiry date, which is a 6-digit number. So 16 plus 3 makes it 19. 19 plus 6 makes it 25. So I've got a 25-digit stream. So I again need to provide a protection to it. So if my bank is creating a blockchain exclusively for providing a protection to a data of the customers belonging to that particular bank, we are getting a private blockchain. But yes, if I'm dealing with cryptocurrency, which is being dealt by millions of people around the world, or being trading is being done on the stock exchanges, I'm dealing with public level blockchain and stuff. So let's say my university wants to provide a protection to the marks scored by the student in particular exam, right? So then this kind of data is very personal, very private to that particular university. So the controller of examination can take an initiative that he can ask the IT team of the university, or maybe talk to some of the companies if they don't have expertise, that design a blockchain for me which only stores the information about the data of the student belonging to studying in that particular university. So that is a private blockchain, because that's the kind of initiative we have taken in our university. We are now providing protection to a data stored by the student within our own different BTech program, which we have now got in our university, artificial intelligence, data science, machine learning at Guru Gobind Singh Indraprastha University. So we've taken the initiative in that, and yes, in the times to come, the entire data might get migrated from the normal NAIF form to the private blockchain, exclusively to my university. Now, Dept, if you look at 7,61,780, that many number of blocks have been added to the blockchain still now. Capacity, distance, how many years? 13 years, 9 months, 27 days, 3 hours, 11 minutes. BTC value, so many amount of information you will get. So this was the first block, not much you will find able to find it. But if you look at the current block of the blockchain, yes, a lot many number of the information will be able to find as such. So this was the first block ever to be created in the area of the blockchain technology. Let's come to the current block, latest block of the transaction. Yeah. Now, if you look around, if you look at the previous slide, what it says, the Bitcoin block one depth was 761,780. Now, this is the latest information. 761,780 means just like 49 minutes 51 seconds back only. The latest block was added to the global blockchain. That's how that was the first block ever to be created by Satoshi Nakamoto in the blockchain, and this is the latest block which has now been mined by some entity. Now, at times they reveal their name, at times they don't reveal their name. These are the corresponding hash values. So as I said earlier, either you use an algorithm like MD5 or SHA. There's also Blowfish algorithm, the Whirlpool algorithm, all the hashing based algorithm. Or you design and develop your own private hashing technique, which can be used only by your organizations. So this is the mind, that means how long they were created back, transaction count, size is the number in bytes, how many size, what is the size of that particular block. And if you look at this is the block. So I will share an example how we create a block so that you can have a broad understanding how it will look like. So this is the block IDs, block numbers, 80, 79, 78, 77, 76, and so on. So this is all happening on the real-time portal, the blockchain.com. If you look at the portal, it's a blockchain.com. So I will just share the same on your, I'm given a permission to share, yeah, on the chat window, so that you can open it on your screen also, and you can see that how does it look like. Coming back to it, yeah, latest block of the block. Is the slide visible? Anyone can again say, because I've just switched from website to slides.
Yes, sir.
Okay, great, thank you. So have you got a broad understanding of blockchain, or that what was the need for the blockchain? Why? Because I want to have the security of the data. What kind of data? No, only the biometric data, the financial transactions. I need to provide a protection to such a data, or the data like we took the example of the marks scored by the students in the university. Most of the universities, which are very old universities, they're 50 years, 70 years, they've got a huge amount of data. They're sitting on a mountain of data, which they need to protect as such. So it could be my companies, it could be my employers, anyone who have a data and they need to provide a protection to such a data, they need to acquire a blockchain. That was the first thing we discussed. Then who introduced the blockchain? Satoshi Nakamoto. When? 2009. How many number of blocks have been added? We have just seen that slide. It's a global blockchain network, a public blockchain platform on the blockchain.com, wherein so many number of the blocks keep on getting added. But all these blocks have got some fundamental features, something what we say three pillars of the blockchain technology. One is the decentralization. We said true meaning of decentralization is something uh, which does not have a single central unit. If you look at the traditional banking system in India, there's a Reserve Bank of India, right? Now they laid down the rules and policies and guidelines which almost all the other public and private sector bank usually follows. So that's a centralized system where one is at the root, just like in a graph we have got a root node, and then we have got multiple branches like multiple bank, HDFC, SBI, Punjab National Bank, Axis Bank. So they need to follow the repo rate introduced by the RBI, the all information about the transactions to be performed, how to be performed, everything they do. So it's a centralized system. But when we talk about the cryptocurrencies and blockchain, we follow decentralization. Let's not have any single organization which controls everything. So we say blockchain are very autonomous in nature and does not have a single centralized governing unit. Another very fundamental feature or the pillar of the blockchain is transparency. Transparency in real life, we all know something which is called zero opacity. So whatever you do, it should be very well known to all the people who are on that platform. Don't hide anything. So it almost follows zero privacy policy. We don't hide the data, we don't hide the information. Everything is known to the miners who are creating a block in a blockchain. What is the immutability? Immutability means something that cannot be altered or modified in a long term. It means that once the transaction has been pushed into a blockchain, it cannot be altered. Right now, if you look at the web-based transaction, you can modify the transaction in the real-time scenario. But in the blockchain, we say once the transaction has been mined, the block has been added to a blockchain. Because if you look at the word, the blockchain means the chain of blocks only, right? So once the transaction has been mined, you are not allowed to modify it, you're not allowed to alter it as such. So when we say what makes the blockchain technology the way it is in 2022, these are three fundamental principles: decentralization, immutability, and transparency. So these fundamentals won't get changed over a period of time. They will remain as it is. They won't get fluctuated for that matter. Now, how will a typical blockchain look like? Let me take an example. Yeah. Yeah. So initially I got first block, like block B, right? Now this is called as a genesis block, the first block of the blockchain. Now it is not connected to any predecessor. So this is the first block. Like it's like we have got a linked list. We have also data structure DSA. We have got the linked list. The first node comes. Now it is not connected to any predecessor node, and we're not talking of circular linked list. We're talking of sequential linked list, right? Now there is the next node after it. That's called the second block, B1. So this is the B0 and the B1, and there is a certain amount of data that moves from the B0 to B1. Now, what kind of data we're talking of? That means minimum four essential information, like what is the hash value of the previous block, right? That is the information we need to pass. What kind of data I'm trying to secure in a blockchain? Now that is a very popular word is the fiber data. That means financial, insurance, banking, educational data, the transcripts, the UG and PG and PhD data, all the electronic medical records of the patients in the hospital management system. So what kind of data I'm trying to protect using a blockchain? Then the timestamp, and then I need to decide again on the hash value of the current block. So overall, every block contains four basic information, minimum. There could be more to it, but yes, minimum it should contain the hash of the previous block, then the data, the payload, which I want to secure using a blockchain technology, the fiber data, then the timestamp, and then again the hash of the current block. So every block except for the Genesis block. Genesis block is not connected to predecessor block. So it will not have the hash of the predecessor block because it's the first block. But except or excluding the Genesis block, all other block of the blockchain will have minimum four amount of information: the hash of the previous block, the hash of its own self, then the data, the payload part, and the timestamping. So all this information moves from block to block to block to block. And theoretically, I haven't come across in any way literature that there's a limit on the number of blocks that can be added to a blockchain. It all depends upon the resources, the computing resources you have. As long as your computing resources supports it, fine enough. You have that much amount of primary and secondary memory on your systems, you can keep on enhancing, you can keep on concatenating, or you can keep on mining more number of the block in a blockchain. So theoretically, academically, there's no limit. You can add as many number of the block in the blockchain. And we are not talking only circular linked list, so no circular blockchain exists as such, right? So this diagram makes the blockchain. This is the basic fundamental diagram, very simple diagram, nothing complex about it. If you have studied the DSA, it's all good. You need to have the chain of blocks all connected to each other in a sequential manner. The first being a genesis block, and all other block containing four set of the values, the hash of the previous block, the data which I want to secure or protect using a blockchain technology, then the time stamping, the actual date and time, because we have seen that in the blockchain.com, the timing was there, year, month, date, and even the hour, minute, and second. Everything was time stamped. And then the hash of the current block. So I can have the multiple number of the block adding to the blockchain network, maybe a global blockchain network or as a local blockchain network. That's how the typical blockchain look like. If you're a naive person beginning starting for the very first time, this is what the blockchain is all about. So how it will look like? Something like this. We'll have the genesis block, what we call B0, the block 0, which is does not contain the hash of the previous block. So hash, it's all empty part. Then the data, then the timestamp, then the hash of the current block, right? The hash of the block 0. Then I've got block 1, hash of the block 0, data, timestamp, and the hash of the block 1. Then the block 2, block 3, 4, 5, 6, 7, 8, 9, and I can have any number of the block in a blockchain. That's how we can go and populate the block within a block. And it will keep on expanding. It can go on over a period of the time. Now, this is what, I'm not going to much of the details for the simple reason because I'm not sure what is the level of the students who are studying, understanding it. Now, to understand a blockchain, is this site visible? Anyone can say yes or no?
Yes, sir.
Yes, sir.
So if you are a beginner, if you're starting for the very first time, what did the government of India has done? If you have got understood what I've just delivered using the slides, let's go and implement it using this blockchain virtual lab. So this is if you can see out the initiative, it's by the virtual labs by MHRD, which is now Ministry of Education, an initiative of Ministry of Human Resource Development under the National Mission on Education through ICT. So they have collaborated with the IIT. If you look at the URL also, it's IIT Bangalore. And they have designed and developed a virtual lab for the understanding of the common students. So because not everyone need to be security expert, right? So if you're starting for the very first time, you want to have broad understanding what the blockchain is all about, just go and hook up to this virtual lab. It's a very good lab. If you look at the multiple tabs here, the first is the AIM, wherein they have talked about what is a blockchain. Then they have talked about a bit of theory about the blockchain, where they have come up with the decentralization, transparency, and immutability principles. Then they've given you a pre-test that are you a right person to start with the blockchain? So then you can give a pre-test, a pre-request part, right? Then what is the procedure? How you can go and design and develop the blockchain. So they're given a broad understanding of the things within their simulation. Then the simulation part. Let's come to the simulation. So multiple small experiments are there. Let's do it for the understanding of everyone. Now, we've got a small graph here, right? 4 nodes are there, A, B, C, D. And this is the first experiment here, where we start learning how to create a blockchain. So let's say I want to connect 2 nodes. So I click on the source node A, I move my cursor, click on the destination node B, and if you see a edge comes, connecting the 2 nodes A and B, right? Same way I start with the node B, I keep in the source, I connect it to the node D, again an edge comes, connecting from source to destination. Then I click on the node D and go to the destination node C, again an edge comes. Now I want to check what I'm doing is right or wrong. Is it following the principles of blockchain? So I click on this part, validate, just check it out, right? And you can see a notification pops up. It is valid. That means the blockchain which I'm creating using connecting all these blocks is perfect. It's following the principles of the blockchain. Now, knowingly or unknowingly, I connect the node C to the node B. So I bring my cursor to the node C, I go to the block B and I connect it, right? So I've connected the intermediate nodes. And I want to check what I did was right or wrong. So I click on this validate button, right? and I can see a notification pops up. The notification number 2, it's invalid. Why? Because blockchain does not allow the intermediate nodes to be connected. That's like the end node, the destination node, the leaf node getting connected to one of the intermediate nodes, because that will disturb the hashing sequences. So it will not allow such a kind of situation to arise. Because if you look, every block is carrying 4 things: the hash of the previous block, the data, the timestamp, and the hash of the current block. Right? So if you start intermediate connecting, then the hash sequences will get disturbed. So it does not allow to connect to the intermediate nodes. It just follows sequential information. So that's the very first basic experiment available in the blockchain virtual lab. So I can share the URL in the chat window so that you can also do it along with me. So that's a fun and the enjoyment you get by working on these virtual labs. You can simulate in the real-time scenario. I come back to the lab again. Yeah. And I go to the second experiment. What we say, click on the button on the right-hand side, initiate open ledger experiment, right? And now you can see here, yeah, option comes, enter the name of the user A, enter the amount given. Right? What I did now, this is again open ledger experiment, wherein you need to perform the transactions. So let's say I enter the name of the user, I fill in the blanks, I say Amit. I give the amount, let's say $100. Well, let's say 100 is good enough rather than keeping 1000. And I say submit. So I can see here from system to Amit, amount is $100. System here means the, let's say, government or any company who, let's say, in the time of the COVID, we have seen the government has given direct beneficiary transfers to the account of the poor people, the EWS section. The money has been transferred to the account holders. So government has Jan Dhan accounts of the people, the BPL people, below poverty line people, or the EWS, economically weaker section of society. So they have transferred certain amount of money so that they can survive when the entire world was locked down and then their businesses, their operation has come to standstill. So system here is an entity who is transferring certain amount of the money into the and archiving it in the block of the blockchain. Now it says enter the name of the user. Let's say Amitabh. It says enter the amount given. Now Amit has got $100. Now from that, let's say he's taken a loan from Amitabh. It transfers $50 to Amitabh. So immediately, if you see this open ledger, a second block comes where Amit is transferring certain amount of money. A transaction is happening where $50 is getting transferred to the Amitabh. Now it says, do you wish to continue? Radio buttons are there. I click on yes. It says enter the name of the user. Let's say I say Amita is transferring certain amount of money to Savita. She has got $50. So from that $50, she transferred $25, right? And click on the submit. Now again, you can see another block emerges out. So that means now I'm creating a block of the blockchain I'm adding. Now, which is a blockchain? Public? No, I say it's a private blockchain. Being managed by a single company or by the banks only for its own account holders, right? So it's a private blockchain, what we are talking of. And then I can keep on adding more block in a blockchain. That's how the second experiment goes. Let's come to another small good experiment to have understanding of the blockchain. If you click on this button on the right hand side, the experiment will come. Now here, if you can see here, the immutability experiment, there are certain nodes, node A, B, C, which are all vacant. Empty spaces are there. Now as a person, as a student working in the blockchain virtual lab, you can add certain amount of transaction information. So blocks are available. Block A, block B, and block C. All these blocks have certain amount of transaction information attached with them. So if you say A is transferring certain amount of money to B, B is transferring amount of C, again B is transferring certain amount of money to C. So let's say if I am the student of the virtual lab, I pick up a block of a block. I do a click. And I see the border of a block comes green in color. I bring my mouse cursor and release on the node A. So I say the copy of the block A is now archived in the node A, right? I do the same for block B. I bring my mouse cursor on the block B, click it, the border changes, I come to the node A, releases it. So block B is now archived in the node A. Same I do it for the block C. Same again I do it for the node B, block B, block C. I redo it again for the node C. I'm archiving certain amount of the information into the nodes. A, then comes the B, and then comes the C. So I'm following a very sequential approach. That is what blockchain 𝑘𝑒𝑚𝑢 for me, and I want to check now what I have done is right or wrong. So there is a button here at the push buttons are there. Click on validate just to check whether everything was right or not. So you look at the notification pops up, valid. That means whatever you did was right, following the principles of the blockchain technology. Now I am a nuisance kind of a user. I want to fiddle it. I want to check. So what I do is reset. I have cleaned off all the nodes A, B, C, and now I go again to the block A. I redo the same task again, but I will do something different. Let's see. Node block A, block B, block C. Again, I pick up block A, block B, and the block C. Right? Again, I take the block A, go to the node C. Now, instead of block B, I bring the block C first and archive in the node C. Then I pick up the block B and archive in the node C. Right? Now, this raises a question mark. Can I do that? Can I shuffle the sequence of the block in a blockchain? I know the answer is no. I can't do that because I will violate the basic principles of the. Still, I've done it, right? And I want to check whether what I did was right or wrong. So I click on the validate button again, and I check on the notification number 2 that pops up. It says order of the block is different, and therefore it is invalid because again I violated the basic fundamental principle of the blockchain technology. I should not be doing that. I cannot change the sequence of a block which are going to be archived in the blockchain. Otherwise, what will happen? The hashing sequences will get disturbed. The pattern which are being created by using a sequence by addition of sequential block in a blockchain, that is getting disturbed because we are shuffling the order of arrangement of a block in a node, and that violates the fundamental principles of the blockchain technology, right? So these are small experiments that how you can design and develop, or how you can simulate the block in a blockchain. Now, since the talk is of 1 hour, so we won't go into the programming aspect of it. But yes, I have shared my, I have got my YouTube videos wherein I have also demonstrated how to create, how I can do that. So, if you are interested, I will just share the link. You can go through that video and maybe have information about the blockchain, how to design and develop. That's my YouTube channel actually. I keep on uploading various amount of the information for the benefit of the student community. So I keep on working on blockchain, like the Merkle tree formation, how to do it, how to design and develop using a remix and solidity. But if you're how to use the MD5 and SH algorithm for hashing concept, and there's certain videos on the cloud computing also. So if you want to have a more idea that how we can actually do it in a real-time scenario, again, I'm sharing a link of the YouTube channel. If you're interested and if you have a time, you can go to the Merkle tree formation of the blockchain technology, how to design and develop a smart contract. Because nowadays, many companies are working for the creation of the smart contracts. For example, a smart contract is again a contract between the multiple number of entities. Like I take a medical insurance from certain company, right? ABC company. We don't take the name. And we have seen in the times of COVID that you have fallen ill. Many people have lost their savings also. And suppose I fall ill, I go to the hospital, and in hospital I just need to show my card, what we say health insurance cards. Now at that point of time, the smart contract says don't have to worry about it. To the smart contract vendor who is creating this contract for you, you have already told everything about it. So you just need to inform to the vendor, and everything will be taken care of by the company, as the medical insurance company. So smart contract here means a contract between the customer, the hospital, and the medical insurance company, so that the customer does not have to worry about the money aspect, and it cannot be changed. So once the contract has been decided, it can't be changed in a real-time scenario. So you need, and the beauty of the smart contract is that nowadays we've got full digitalization. No paperwork is required. The contract is all digital based. The card will be issued to you. Not even in the nowadays we're on a card only coming as an app on the smart handphones. You don't need to even carry the physical card. Your card will have a barcode, a QR code. You just go and show it, scan it on the hospital authorities or at the hotel authorities, and the smart contract for you will get activated. And instant payment will be taken care of by the execution of the contract. So it's a big thing that has come up. Already it has come up. So I'm not talking of anything which is going to come in the near future. Already for the last 2 years, many smart companies are moving toward the smart contract features. Then Ethereum is again a good video wherein you can come about the how to actually deal with cryptocurrencies on the remix IDs and on the Ethereum platform as such. So that is what I have demonstrated here. What is the gas here? And if you want to go for the basics of the fundamental, going from the MD5 and SHL algorithm, that's another video, AV, audio video that talks about the beauty of the hashing technique. Because there are two ways on how I can onboard on blockchain. One as a programmer, right? Then I need to have a knowledge of MD5 and SHL, but the hashing technique. So I can design and develop my own blockchain for that matter. Alternatively, I don't need to do hardcore programming. I just go and design and develop the smart contracts wherein I use the remix and the solidity IDs, and I can easily do it. So I need to define what is my role in the blockchain and how efficiently I can do it. So with that, I would like to conclude the talk. If there's any doubt, I will be happy to answer the questions. Please feel free to unmute yourself and let's have a one-to-one session if you want.
Hello, sir.
Yeah, Shivam.
Yes, I just wanted to ask about the Genesis block that you just described.
That is the first. Yeah, please go ahead. Abadai.
So with the Genesis block, so how it is formed? You just told just how the data. It has no data, right? The first block. So the transaction of the first block, is it itself in the Genesis block or something else?
It is. The first transaction which is going to be created is going to be archived in the Genesis block of the blockchain. Because every time, like what we the example we took from blockchain.com also, Satoshi Nakamoto in 2009 created a Genesis block. And thereafter, the world has been adding more block to that particular blockchain on the blockchain.com. And right now, 7 lakhs plus block have been added. So it's an initial. That's what I took the example of linked list also. You need to start it. The first block or the root block of the entire blockchain is called the Genesis block. So if I'm designing and developing a private blockchain for my own organization, I will start the things. And then later on, more transactions can be created, more block can be mined, and they can be added to the blockchain.
Okay, sir.
Any other doubt or query? Yeah, there's a question by Neeraj. There's a lot of hype going on about blockchain, but what exactly is the future of blockchain developer in India? It is bright. See, why I say this is bright, because blockchain is a part of the information security domain, and security domain is evergreen domain. You can't have a day where you can have 100% bug-free, foolproof, secure products. It is impossible. Actually, it's a race between the hackers and the security experts. Security experts design and develop a product keeping the secure technologies in mind. Hackers are equally smart. They try to break the technology in a very short span of time. So on the scale of 1 to 10, if the level of security expert, let's say 8 or 8.5, who is good in mathematics, who is good in algorithm, who is good in programming, but the level of hackers is almost 9 to 9.5. Rather, just like, for example, we can take, when we talk of the web, there are two kinds of web. One is surface web, one is a deep web or dark web. Surface web is something what we work on. All our web browsers work on surface web. Google, hotmail.com, yahoo.com, rediffmail.com, we all work on surface web. But most of the hackers work on the deep web or dark web, which is very popular for the nefarious activities. All the illegal activities, anti-law activities usually take place, like the sale of submarines, nuclear submarines, casinos, online gaming, pornographic activities, almost all the activities are banned by the court of law of the particular land. So they are usually taken in deep web or dark web. So security experts does their job, but these hackers and attackers are very, very smart as such. So since the security is evergreen, so is a blockchain technology. Blockchain technology does not stand alone. It's only a technology for the security of the data. So let's say there are 4 or 5 hashing techniques. And now, because if you use MD5 or SHA, as a hashing technique for your own private blockchain, then you're doing a blunder. Why? Because the RFCs, the request for comment, the RFCs of both MD5 and SH are already on the web. So if you know about it, the hackers also know about it. So immediately they will be able to decipher it. So as a security expert working for like TCS or Wipro or Infosys or Grape City or Accenture or Negaro, if I'm a person working, a technical developer working with one of these security teams, so it's my responsibility not to use open source MD5 and SHA, but I need to design my own hashing technique. For example, if my credit card fraud takes place, right? I'm using a SBI credit card. Fraud happens with me on the web. Should I blame the bank? The answer is no. Bank are just the bank, traditional good old bank. They still believe in that paperwork only. But most of the bank have outsourced their IT operations to these IT companies. TCS, Wipro, Infosys, Grape City, Accenture, Negaro, and so on and so forth. So if my security fraud happens, I should not blame the bank. I should blame these IT companies. Rather, programmers working in these IT companies and security teams, that they were unable to design and develop the secure algorithms which could provide a protection to my data on the web. I think that should make my point very clear. Here, there's a future, very bright future of the blockchain for that matter. Then Aman says, can you tell more about the Ethereum blockchain? Yes, I have shared my YouTube channel link. If you're interested and if you have a time, please go through it. And I can share my mail ID also. If you've got a doubt or any problem regarding, even after seeing that video and still not clear, you can shoot me a mail at rahul@ip.ac.in. I will be happy to answer it. What are the programming requirements for developing a blockchain? Sumit asked, yes, Sumit. Sumit, we have got something called Java cryptography architecture, JCA, what we say. They provide the inbuilt APIs for MD5 and the SHA algorithms. So JCA APIs. API is the application programming interface. So I can use a predefined APIs provided by the Java to design and develop my own blockchain. Also, nowadays, not many people are working in Python. So if you're good on working knowledge of Python, you can use any one of them. So from my side, the recommendation is either you go for Java or you go for Python, and both of them are open source. So you don't have to pay anything to anybody, and you can still end up designing your own blockchain. Any other doubt by anyone? So thank you so much for having me then. I've already shared my mail ID. I will be happy to answer any questions on online basis also. So can I take a leave? Can I ask the ACM chapter faculty sponsor or the chair? So do we have one doubt about YouTube live stream? What level of understanding of cryptography do I require? Yes. I have not uploaded any YouTube videos on the cryptography as a subject, because if you want to have a good knowledge of cryptography, I will recommend the books or tutorials or documentation by 𝘍𝘭𝘰𝘤𝘪. I'm just typing the name, and they're world-renowned authors, and William Stallings. Please, you can have a first level of study by the books of these two authors, 𝘍𝘭𝘰𝘤𝘪 or William Stallings, and there are many more books also. There are many number of the NPTEL videos or the Coursera or the OCWs or the MOOC courses also, which are dedicated to the cryptography. But then knowledge is required. I don't say you should be expert in the area of cryptography. No, not required. But yes, fundamental knowledge is required, that what is cryptography, what is symmetric and asymmetric, what are the different Caesars, what are cipher techniques, and the cryptographic algorithms. Because once you have a knowledge of cryptographic techniques and the cryptographic algorithm, then you come to the hashing techniques, and then come to the actual blockchain as such. Because you will be able to understand the hashing technique only if you've taken the path through cryptography. If you directly jump to the hashing, I don't think so most of the people will be able to understand, because you're skipping the fundamentals of the subject as well. Though people might pick it up. It all depends upon their own level of IQ, how much they are able to pick it up. But yes, better follow proper path rather than jump on the bandwagon and just rush doing something on blockchain. You skip the basics of the subject. NFTs, non-fungible tokens, yes, it requires another lecture. I don't want to mix so many things and create a confusion in the minds of the students who are attending it. Maybe some another day, another time we can connect for the NFTs also. But yes, NFTs are the future, no doubt. Non-fungible tokens are here to stay, and they have a future ahead. Okay then, thank you all for having me for this online webinar. And thank you to the ACM also, ACM India Council for organizing this activity. Thank you to the ACM Chair faculty sponsor of the college for arranging this webinar. So shall I take a leave to the ACM also, ACM India Council for organizing? Or maybe some of the students and faculty members who are present, we can switch on the video and send, rather photographs. Can have the.
Excuse me. Hello everyone. On behalf of ACM PCCOER, I would like to thank Dr. Rahul Johari sir for this intriguing session on blockchain.
Maybe they can switch on the camera and we can have a quick photograph so that they can send to the ACM also.
Vaishnavi, all of you are requested to turn on your cameras, please, so that we can have a photo screenshot of our screens. Students who are present, please turn on your cameras. Vaishnavi. Vaishnavi, are you there?
So this time we have got an online lecture, but next time when I will visit Pune, I will visit the college also. We'll have an offline session where I can interact with you.
We were actually expecting you to be there in offline mode only, but due to some time constraint, we could not manage the things.
True.
So definitely we will invite you for special kind of activities as well in our campus. So we generally conduct various conferences and workshops in our campus. So definitely we'll be inviting you for that, sir.
And we'll be happy to interact with you all.
Yes, sir. So I think I'm done with my taking screenshot. So now I will extend a vote of thanks to. I'm very much thankful to Rahul sir for sharing his expert knowledge with our students, and definitely this domain our students have got sufficient knowledge about this particular domain, and they will start working on whatever the research inclination that you have given in during this session. So I assure you, sir, that definitely with our next interaction, our students will be having some basic knowledge and research-oriented knowledge. So thank you very much again for sparing your valuable time.
Thank you, Mahendra ji, for having me. Thank you so much.
Thank you, sir. Thank you very much.